Would you like to introduce your role?
Sure thing, sure thing. So, my name is Eissa, Jamil. I'm a AI partner engineer at Meta, and I work with Llama. And I work with a lot of the partners that are deploying Llama, like AWS, Microsoft, GCP, Databricks.
What are some other use cases of Llama?
You would have previously used like more traditional ML models for classification. Those are capabilities that are now baked into a lot of LLMs too. So you can think of classification problems. You can go and use entity extraction.
Do you have any advice for students who want to learn about large language model?
Understand transformers, but then understand how weights are actually playing into this, how the different layers are functioning, and then how does that actually train when you're going into pre-training, etc. Having that foundational knowledge helps you understand what's going on when that token by token analysis is occurring to give you a generation. Understand what are the limitations of prompt engineering versus the necessity to expand to something like fine-tuning or continuous training.
Hi, Eissa. Would you like to introduce your role and what are you here about?
Sure thing, sure thing. So, my name is Eissa Jamil. I'm a AI partner engineer at Meta, and I work with Llama. And I work with a lot of the partners that are deploying Llama and making Llama available for people to run inference, fine-tuning, training jobs by providing either infrastructure or tooling, stuff like that. So you can imagine companies like AWS, Microsoft, GCP, Databricks. Those are a lot of the customers that we end up working with. So that's what I do at Meta.
In academia, I can think of using Llama just to write a Shakespeare poem. What are some other use cases of Llama?
So I think the use case you just mentioned, super interesting. That's a fun one, definitely. And I think that's one that you should definitely experiment, like the creative side of using LLM for generation. But then there's a lot of other use cases that you could think of that maybe you would have previously used like more traditional ML models for classification. Those are capabilities that are now baked into a lot of LLMs too. So you can think of classification problems. You can go and use entity extraction. Say you have a large corpus of text, you want to extract certain data points or entities from that. You can go ahead and do that via various techniques, whether it be prompt engineering techniques where you're doing entity extraction or summarizations, or you can do it even in a way where you go and fine-tune those models for the domain you're working on to get more specialized data and deep information if you're going to stuff like that. But it's really dependent on what you're trying to solve. There's a variety of things. If you wanted to do something like analyzing a large corpus of structured data or even unstructured data, you can do that to extract certain ideas, metrics, or analysis. But it's really dependent on your use case. And that's the cool part about the LLMs, and it's the cool part about the space right now, because students and universities are able to also do this and do research on kind of groundbreaking new stuff, which we don't necessarily even know about. So I don't know if that answers the question.
Of course. Llama is an open source model, but how to use it if we don't have GPUs?
Oh, that's a tough one. Okay, so Llama's open source. You can get the weights yourself. Now, running those weights does require compute. Compute on GPU is nice, especially if you have a lot of power. But we do release a number of models. So Llama does release in various forms. We have the smaller models that are designed for the edge inference. Those are like 1B and 3 billion parameter. We have an 8B model. We've got larger ones like 70B and 405B. Those are obviously going to be more complex to be able to run. You need more compute. You probably would have an issue running that locally unless you've got servers with GPU power behind it. But you never know. I mean, universities do have a lot of resources. The smaller models, though, you could run on a lot of your normal laptops. Like a 1B model, 3B model, you could probably load on laptop with Llama as an option, or run it with PyTorch itself. But there's a lot of different ways you can do it. A lot of good examples, whether you use our GitHub repo, which is the Llama Cookbooks repo. It was originally called Llama Recipes. Okay. But check that out. There's a lot of like getting started ways to get it going.
Okay.
Yeah.
If students want to get started with Llama, where can they find information?
So it depends on what they're trying to do. So if you're just a student, you're trying to play around with an LLM, my recommendation is try to use a hosted API to learn how to use it. And the cool thing about that is a lot of the hosted APIs give you like a free X amount of money to use for inference. And a lot of times, if you're using the small models, it's pennies to run inference. So you can use that for quite a long time until you start really finding a use case that burns through those token counts. That's how I would get started learning how to do inference, learning how to prompt engineer. If you're going to do something deeper, then I would start learning how do you actually set up an inference server? How do you load it? How do you serve with like VLLM or TGI? That's the next step. And then if you're going into the training side, I would probably start with looking at like PyTorch and TorchTune and look into the tutorials we have built directly in the PyTorch website. There's some really easy, simple walkthroughs, but running those locally is going to be difficult without GPU power. So that's the only issue there.
Thank you. And the last question is, do you have any advice for students who want to learn about large language model?
Yeah, that's a really good question. So with large language models, advice I would give is one, understand kind of the underworkings of LLMs, especially for a CS student or like a student who's trying to learn how this works with an AI. Understand transformers, but then understand how weights are actually playing into this, how the different layers are functioning, and then how does that actually train when you're going into pre-training, etc. Having that foundational knowledge helps you understand what's going on when that token by token analysis is occurring to give you a generation. And it also helps you understand when you go into doing some fine tuning, what's going on and how are you modifying those weights, whether you're doing like FSDP or you're doing something like PEF, LoRa, QLoRa, what's going on. And then having that understanding also allows you to understand when you go into quantization, what's the effect of that. So that's one of the things. So understand that base knowledge a little bit more. Understand prompt engineering from the extent of what are the limitations of prompt engineering versus the necessity to expand to something like fine tuning or continuous training. When do you need to do that? Having the foundational knowledge will help you make those decisions, but those are probably critical things to understand. All of that comes back to understand, do you have enough data to go along with all of this? Is it necessary to go down training, all of those things? But again, having that root information is the first step.
Thank you so much.
Awesome.
Hi.